In this chapter, we'll be looking at consumer choice. We'll be evaluating consumer happiness, how much value they get out of certain purchases, and determining like their best or optimal combination. We're going to start by looking at the demand curve and consumer surplus. So we'll be looking at the market as a whole. Then we're going to go down to a more individualized level where we're looking at utility and indifference curves. These are ways of representing consumer preferences, how much happiness they get from consumption. We're going to add in a budget constraint, which includes prices and income. We'll talk about rational spending rule and the income and substitution effects. All of the things in this chapter are going to help us understand how consumers make optimal choices. First, let's start with market demand. This actually represents consumer preferences in a market when we combine all consumers together. So the market demand is all of the individuals added together. There's different ways that you might see this represented. This is a graph taken out of your book, figure 7.5. And you'll see on panel A here, the graph on the left shows you 3 different individual demand curves. So it shows you the demand for Andrews, the demand for Kano, and the demand for Smith. The market demand is panel B, it's this graph on the right, and this actually combines all 3 of those demand curves into one market demand. And we're going to do this horizontally. So we're not going to add the prices together. What we're going to do is add the quantities together. So we're going to look at how many apples are demanded at $2, how many apples are demanded at $1, and we're going to get our market demand. So let's start with $2. So Smith is going to demand 3 apples. Andrews is going to demand 5, and Kano is going to demand 8. So when we add those together at $2, all 3 of our people in our market demand a total of 16 apples. So we plot this on our market demand curve. And then we do the same thing for $1. So at $1, Kano wants 10 apples, Andrews wants 12, and Smith wants 18. So we add those together and we get at $1 our market demand is 40. So we're going to add these horizontally. Each individual consumer has their own demand, has their own preferences. We could see that Kano likes a similar amount of apples, whether they're $1 or $2, whereas Andrews likes way more apples. I guess that's, no, Smith. Smith likes way more apples when they're $1 compared to $2, and then Andrews is kind of in the middle. These preferences can change, so an individual can drop out of this market. They can like apples more, not like apples. Individual incomes can change, but our market demand will still follow all those same rules that we learned back in chapters 3 and 4. We can calculate the total consumer surplus in our market by looking at that market demand curve. Now, if you remember, we did talk about economic surplus earlier in the semester, and economic surplus is going to be the extra value or extra profit that our buyers and sellers get that's different from the purchase price. So we're going to start by just looking at consumer surplus here, and we'll do producer surplus in a later chapter. The demand curve shows our highest reservation price, that maximum price consumers are willing to pay. But we also have a market equilibrium price. So in this market, everybody is going to pay $4, regardless of their reservation price. So one person in this market may like it $9 worth, another likes it $7 worth, someone else likes it $6, someone else likes it $5.25, but everybody still has to pay $4. And so the people who have these higher reservation prices end up with something that we call consumer surplus. And that is the extra value that they get that they didn't have to pay for. So extra value like above the purchase price. up to the demand curve. Consumer surplus, you can think of this as like buyer profit. It's easier to think of producer profit, right? If it cost them $2 to make and they sold it for $4, they've got a $2 profit. Or if it cost them $1 to make and they sold it for $4, they have a $3 profit. Producer surplus, producer profit is just easier for us to think about because it's an explicit value. Consumer surplus, we have to use our imaginations a little bit more, and we have to understand that people do have a reservation price that's different than the price they actually pay. And some people are good at knowing their reservation prices, but honestly, I think most people don't ever think about it. Personally, when I go to the store or I want to buy something, I'm looking at it and then I check the price. And like, if I'm like, oh, that's really expensive. Oh, that's not worth it. I'm not going to buy it. And my assumption is that my reservation price is probably lower than whatever that price tag is. Or other things, you look at the price and you're like, this is a great deal. I don't care about the price. I'm buying this no matter what. Probably have a much higher reservation price. But personally, I don't really know my actual reservation prices for things. I just know if I see the price of something, if I'm going to buy it or not. So this is going to be more of a thought exercise. We understand that people do have these maximum values. It's much harder to estimate in real life than producer profit. We can actually calculate the consumer surplus for the whole market. In this case, because we have straight lines, we are going to calculate the area of this triangle here. So we're going to start at the price. That equilibrium price is going to be our horizontal line. We're going to go all the way up the y-axis until we get to that point where demand hits the price axis. And then we're going to go down along the demand curve all the way to the equilibrium. So the demand curve represents the value to buyers. The price represents what they had to pay. And then anything between the demand curve and the price is that extra value, that consumer surplus they get. We're going to use the area of a triangle formula, which is 1/2 times the base times the height. So in this case, the base is this horizontal distance. So it's however far it is from here, which is 0, all the way to the equilibrium, which is 60. So our base is 60. Our height, we're going to go from $4, that equilibrium price, all the way up to 10, where it hits that axis. So we'd say our height is $6. And then we would just plug that in. So we'd say 1/2 times $6 times 60. And we're going to get that our consumer surplus is $180. So it's going to be a dollar value. It represents money that our consumers would have paid, but that they did not have to. The very last person who has a value or a reservation price of $4, they pay $4. Their consumer surplus is 0. And that's okay. 0 surplus is fine. It means that you're getting the value that you paid for. Negative, we do not want negative surplus. So the people over here who value it less than $4, they should not participate in this market. They should go buy something else. I'm going to give you this example to practice, so pause the video after I explain it, okay? So you are going to calculate the consumer surplus in the market for milk when the price is $2. So pause the video here, calculate that surplus, and then we will go over it. All right, so we're going to use the formula to find the area of the triangle. So 1/2 base times height. In this case, our base is 80, looking at this horizontal distance. And our height is going to go from $2 up to 10. So your height's going to be 8. And so we're going to go 1/2. 80 times $8 is going to give us a consumer surplus of $320. So consumer surplus of $320 means consumers valued their purchases by $320 more than what they paid in total. Consumers have a limited amount of resources. They need to best decide how to allocate them. So we're assuming consumers are maximizing their profit or maximizing their consumer surplus. They're going to buy the combination of goods and services that gives them that most extra profit. Buying a combination of products is going to be better than just spending all of your money on one thing. In your About Me assignment, I asked if you'd rather just eat your favorite food all the time and nothing else, or if you would rather skip your favorite food forever so you could eat everything else. And most of you said you would never eat your favorite food again because variety is more important. Some of you try to get around this by picking a food that's very broad, like you like pasta or sushi, so you're including all those varieties. But I say you need to narrow it down even more. So if you said sushi, you have to pick like the one roll that's your absolute favorite, and that's the only thing you can eat. You can never eat any of the other sushi. Or the one type of pasta and one sauce that you like the most and nothing else. And a couple people will still maybe pick that one thing, but generally consumers prefer variety. We get more happiness from combinations of different things than all of one thing. We also have to try to maximize our surplus given the fact that we have limited budgets. So things cost money, and there might be one thing that you like more than another, but the price is so much more expensive, you may end up getting more happiness per dollar from that cheaper item. So we're going to take individual preferences, prices of goods, consumer income into account, and try to figure out those optimal combinations for consumption. Individual consumers make choices based on their own preferences, how much enjoyment or satisfaction they get from consumption, enjoyment, value. We're going to say this is called utility in economics. Now, measuring utility is tricky because these are just personal preferences. The first thing is that we are going to say that utility is ordinal and not cardinal. These are math terms. So ordinal is a ranking system, like you're measuring something first place, second place, third place. You're picking the order in which you like something. Cardinal is like actual absolute values. So $10 is twice as much as $5. So let's look at an example. So ordinal, let's say we have a race and someone comes in first, someone comes in second, someone comes in third. Okay, so those are the ordinal numbers. The cardinal numbers are going to be the actual like time that the people ran. So let's say this is a mile, and first place came in at 5 minutes and 45 seconds. Second place came in at 5 minutes and 50 seconds. And third place, which is me, came in at 12 minutes and 45 seconds. So on the ordinal ranking, we have someone who did the best, someone second, and someone third. But the first place runner didn't do it twice as fast as the second place. Or second place didn't take twice as long, right? It's just 5 seconds behind. And then between second and third, it's more than double the amount of time. So cardinal is like the actual values. Ordinal is going to be a ranking system. So when we look at utility, 10 utility is better than 5 utility. But it's not necessarily twice as good. So we definitely know it's better, but we don't know how much better. So we're going to use this as a ranking system. It's also going to be individual. So 10 utility for me does not mean the same thing as 10 utility for you. So I can like something the best, you can like something else the best, but that doesn't mean we get the same level of happiness from our best thing. There's a lot of other things that go into that. So ordinal, 4 is better than 2, but not necessarily twice as good. More utility is always better than less. So our goal in these examples is to maximize total utility. We are trying to get the highest amount of happiness possible. Maximizing total utility does not mean maximizing consumption. There can be too much of a good thing. Have you ever eaten dessert or just something that you like and afterwards you're like, I ate too much. I should not have had that last bite. I'm so sick right now. That was just too much, right? You can have too much of a good thing. So we're not trying to maximize consumption. We're trying to maximize happiness. And so there can be a stopping point. Don't eat that 8th donut, right? Maybe 7 is enough. It's a relative measure for each individual. And we are trying to focus on how we can have the most happiness, most satisfaction from consumption, given the current price level and limited budget. So we're going to go over utility in general, and then we're going to get into some specific examples where we have some graphs and tables, and we can actually calculate, that best combination. Utility is going to be the way that we represent happiness, enjoyment, or satisfaction from consumption. Marginal utility is going to be the extra we get from one more unit. But our goal is that we actually want to maximize total utility. Okay, our goal is that we want to maximize total utility. However, if you remember back from our first chapter, we're going to use marginal utility to find the best combo, right? Find that optimum level of consumption, optimal level of production. Marginal utility helps us find that best level. But our goal is to maximize total utility. Now, this graph that you see here on this slide, this is from your textbook. In chapter 7, and we've got two things going on. So the top graph up here is showing you total utility from watching movies, and the bottom graph down here is showing you marginal utility per movie. And all these lovely spiky triangle things are really there just to show you how we got the marginal from the total. So for instance, 0 movies is going to give you 0 utility. The first movie is going to bring you up to 36 total utility. And so the marginal is going to be 36, right? Because it's total of 1 minus total of 0. Total of 2 minus total of 1. Total of 3 minus total of 2. Total of 4 minus total of 3. Okay, so you're just subtracting the difference between this total and the last one, and it'll tell you that extra. And the second movie brings us up to a total of 64 utility, which is giving us an extra 28. So we went from 36 to 64, brings you to 28. And then the next movie adds an extra 22, bringing our total to 86. The next movie adds 15, brings our total up to 101. The next movie is adding 9, bringing our total up to 110. The movie number 6 is giving us 5 extra utility, bringing that total up to 115. And then that last 7th movie, there's no extra utility. It's just leaving that total at 115. Okay. So our goal is to maximize total utility. And on this graph, that's going to be at 6 movies. 115 is the highest we can get to. And even though 7 is also 115, it's going to cost extra time and money to see that 7th one, so we might as well just stop at 6. Here we see the law of diminishing marginal utility. So the extra happiness from each additional unit is going to be less than the one before it. What this is telling us is that we like the first movie the best. We like the first movie better than the second movie. We like the second movie better than the third. We like that third movie better than the fourth. We like the fourth movie better than the fifth movie. We like 5 better than 6, 6 better than 7. So the law of diminishing marginal utility tells us that that first movie is the best. Whoops. The first bite tastes the best, right? The first of anything that we do is going to be better than the next ones, than the later ones. We can also get to a point where consuming one more unit will cause negative marginal utility or disutility. It could have negative total utility also, so if it's a big enough problem, it could drop that total utility negative as well. But generally, we would say it just is negative for the last one. So like, let's say they put movie number 8 on here, and it's, I don't know, negative 15 utility. Then on our graph here, point would be about right here, where our total utility would be 100. So we would still have some happiness from watching 8 movies, but we would have had more if we'd just stopped at 6. So you can eat too much ice cream, you can watch too many movies, you can eat too much sushi at all-you-can-eat restaurants. The idea is there's a point where you should stop. And our goal is to maximize the total utility, not the total consumption. So you could watch 7 movies or 8 or 50, But if you stop at 6, you're going to get the most possible happiness from this particular market. We represent utility or happiness through indifference curves. We're also going to have budget constraint, which we'll see in a couple of slides. It tells us what combinations are affordable. But the indifference curves are going to show us how bundles are preferred, the same by a consumer. So if we have an indifference curve, it tells you all the combinations that give that consumer the same amount of happiness. Difference curve represents all bundles that have the same level of utility, all bundles or combinations that are equally preferred. So they're called indifference curves because the consumer doesn't care which combination they get. They're going to be just as happy with point A as they are point B. And then we're going to use the budget constraint in a minute with income and prices to figure out which ones are affordable. So maybe I like 2 movies and 2 popcorns the same as I like 3 movies and 2 popcorns. But maybe I can't afford 3 movies and 2 popcorns, so I'm going to get the other one. And I'll show you how that works in just a second. Indifference curves show the trade-offs between the consumption of 2 goods and bundles that the consumer gets the same amount of happiness from. All right, so let's look at an example. So these are indifference curves. These are based on utility functions and equations, which we're not going to go over the equations in this class. We're just going to have a graph and we're going to have tables. If you do more advanced micro classes in the future, you will get into some of those equations as well. So more utility is better, which is not always more consumption. And it's going to move this direction. So the farther away from the origin on the graph, the origin is at 0.00, the farther out we go in this direction, the better it is, right? The more utility we have. And utility graphs are going to be just a number. So here we've got U45, U60, U75. It could just say 1, 2, 3. It doesn't really matter what the actual value is. We just want higher numbers as we get this direction. So on this graph, U75 is going to be the highest utility that we see here. In which case, point P is our optimal bundle, right? We want to get to point P. It's on our highest utility curve. H is going to give us 60 utility. A is going to give us 45. And it's a ranking system. So it doesn't tell you how happy you are. It just tells us we like P better than H and H better than A. So P is the best. H is second choice. And A is third choice. So ideally, we want to be at P. The problem is we don't know if we can afford point P, so we need to know what the prices of these things are, and we also need to know what this consumer's income is to determine if they can get to that. So not only do we want to be at the best bundle with the highest utility, but we're going to try to figure out what the best affordable bundle is.